Question 8. An atom of argon 37 is ionised by the removal of 2 orbiting electrons. How many protons and neutrons are there in this ion? So the proton number is of course the bottom one down here. The nucleon number is the top one down here. Proton number is simply 18. And the neutron number is going to be 37 minus 18, which gives me 19. 18 protons, 19 neutrons. Part B. What is the charge in coulombs of this ion? So we've removed 2 orbiting electrons, so it's going to have a plus charge. So what we need to do is 2 times the charge on an electron, which is 1.6 times 10 to the power minus 19. No, there's no minus sign here because I've taken 2 of these electrons away, so we'll have an overall plus charge. I suggest in the exam that you write plus to make it clear to the examiner. 3.2 times 10 raised to the power minus 19 coulombs. Part C. Which constituent particle of the ion has a 0 charge per unit mass ratio? Well, any particle that has no charge will have no charge per mass ratio because you'll have 0 on the top of the fraction. And the only part of the atom which has no charge is the neutron. The next part, that's part 1, sorry, part 2. The largest charge per unit mass ratio. Well, charge per unit mass is going to be Q over M. Now for a proton, the mass is going to be quite big comparatively, but for an electron it's going to be quite small. So if I'm dividing by a much smaller number, the electron is going to be the one with the largest specific charge. Okay. Oops. Part D. Calculate the percentage of the total mass of the ion that is accounted for by the mass of its electrons. So to work out the percentage, what we need to do is basically the mass of the electrons divided by the mass of the atom. Although the mark scheme's slightly different with this, but I don't think it really matters. So the mass of the electrons is, well, there are 16 electrons. You might think there are 18, but remember we've removed 2 of these, so there's now only 16. And don't do what I did and put the charge in here. Make sure you put the mass of an electron, which is very small, 9.11 times 10 to the minus 31 kilograms. And then we're going to divide that by, really, it should be the total mass of the atom. So we'd have the total mass of all the nucleons, the mass of one nucleon, 1.67 or so, times 10 to the minus 27. Really, we should add 16 electrons on that. I've not seen a mark scheme that really asks you to do this because 16 electrons compared to this number is going to be negligible. So you can generally forget that. I don't think you'd be marked down if you did. Your answer will be slightly different, but not to 3 significant figures. So that gives us a ratio of 2.36 times 10 to the minus 4. It wants the percentage, so we'll multiply that by 100 to give us a percentage. That's easy enough, just change the indices, which will give us 2.36 times 10 raised to the minus 2, which is our answer as a percentage. No units, it is a ratio. And that's it.